Hold on to your hats, folks, because we're going to do limits involving trig functions. Let's go ahead and get started. So first of all, we know that these two things are true, and you may not have realized it at the time, but we solve these problems using the tables, and we have done these problems before. At this point, this is just something you have to memorize, that if you have sine x over x, the limit as x approaches 0 is 1. And the same thing is true if we take the reciprocal. But more generally, we can say that the limit as x approaches 0 of sine ax over ax equals 1. We could also say the limit as x approaches 0 of ax over sine of ax equals 1. And if you don't know what I'm talking about, I'm just saying if you put a number like 5 in like that, that our answer is 1. The other limits that are important to memorize are these ones, that if we have 1 minus cosine over x, or if we just flip that and say cosine x minus 1 over x, those limits both go to 0. However, when we take tan x over x, the limit as x approaches 0 is 1. So I'm asking you to memorize these, and it sounds a little stressful, but in reality, you're just going to memorize that the sines go to 1, the cosines go to 0, and that tan goes to 1. And it has to look like that. So just take some time to memorize that, or at least have it memorized by the quiz. All right, let's go ahead and let's take a look at this problem right here. On this problem, we have sine 2x over x is equal to. Well, unfortunately, we're missing a number here that we need. And what's that number? If you said 2, you're correct. So what would I have to do to put a 2 there? Well, I'd have to multiply by 1/2, because then there'd be a 2 in the denominator, and that 2 would be right there. But can I multiply by just a half? The answer is no. I'd have to also multiply by 2 over 1. So is it true that a half times 2 over 1 is 1? Why, certainly, yeah, it is. So what I can do is multiply it by a half, and then I can multiply it by a 2, and I haven't changed the problem at all. And here's what this is going to look like. Instead of saying multiplying it by a half, I'm actually going to put that 2 right here. That's the same thing as multiplying by a half. If you don't trust me, that's 1 over 2. That's my 1/2. So then I'm actually going to combat that, I'm going to multiply that by 2. And so now I haven't changed the problem, because here I am multiplying by a half, but then I'm also combating that by multiplying by 2, meaning I've actually multiplied by 1. I haven't changed the problem. All right, so now I'm going to rewrite this, and I'm going to pull that 2 out and put it in front. So this is going to be 2 times the limit as x approaches 0 of sine 2x over 2x. All right, well, what is sine 2x over 2x? Well, that's this example right here, where my a is 2, and I know that limit is 1. So my answer is simply 2, and this answer here is 1. So I drop that down. The answer to that is 1, and my final answer is 2. I know these are tricky, but we're going to do a bunch of them, so I feel like you'd be confident in it. All right, here's another one. What do I want this number to be? Well, I actually want it to be a 2. So what would I have to multiply 5 by to get it to be 2? Well, I'd multiply it by 2/5. Right? What's 2/5? Well, 2/5 would have the 5's cancel, and I'm just left with 2. And so, in reality here, if I've multiplied by 2/5 in the denominator, I need to multiply by 2/5 in the numerator. You can think of it as 2/5 over 1 if you want. So then what I'm going to do is, instead of writing 2/5 over 1, I'm just going to write this as 2/5. All right. So what happens to 2/5 and 5 over here? Well, let me rewrite this like this. You'll see that the 5's cancel, and I'm going to pull this out in front. So what are we left with here? We're left with a 2/5, the limit as x approaches 0, of sine of 2x over 2x. Okay, so then what we have next is the limit as x approaches 0. All this right here becomes 1. I drop down the 2/5. 2/5 times 1 is 2/5. And that's our final answer. So basically all I've done is say, oh, I multiplied the denominator by 5/2. Oh no, 2/5, sorry about that. I multiplied it by 2/5, the 5's canceled, and now I'm left with 2x. But since I multiplied it by 2/5 in the denominator, I had to multiply it by 2/5 in the numerator. All right. Let's try this one. And feel free to pause and try to do this one on your own. Obviously, we're missing a 2 here, which means, and I didn't quite have this down here, but you can presume that to be true, that if I had tangent of ax over ax, that's also equal to 1. I think that makes sense. Again, so back to this, I'm dividing by 2. So how can I combat that? Well, I would multiply by 2, because a times 2, then divide by 2, that's 1. Or you can think of it as a 1/2 times a 2, that's 1. Because I'm going to go ahead and take this 2 out and bring it out in front. So I'm left with 2 times the limit as x approaches 0 of tangent 2x over 2x. Okay, this whole thing right here becomes a 1. And then 2 times 1 gives me 2 as my answer. So I know this was scary at first, but hopefully you're like, okay, I'm starting to see the pattern here. Okay, here I need a 1/2 in the denominator, so I need a 1/2 in the numerator. So I take this 1/2, bring it out in front, and now I'm left with 1/2 times the limit as x approaches 0 of a sine 1/2 x over 1/2 x. Well, this whole thing matches up with one of these, and that's going to give me a 1. So then I'm left with 1/2 times 1. That 1/2 comes from here, and then this comes from here. 1/2 times 1 is, of course, a 1/2. These are getting fun now and kind of repetitive, aren't they? Whoa, this one looks hard, but guess what? It's not as hard as it looks. Well, the first thing you say is, holy moly, cosecant x. Remind myself what that is. Well, a cosecant x is actually equal to 1 over sine x. You memorize that in pre-calc. So we need to rewrite this as the limit as x approaches 0 of x times 1 over sine x. Well, what is that going to be equal to? Well, I can just put this x over 1. That's going to be the limit as x approaches 0 of x times 1 is x over sine x. And now that becomes one of these problems where a is 1. And of course that limit is 1. Woo! Loving this. All right, next one. The limit as x approaches 0 of sine of 2x over sine x. I hope you're still watching this because this is totally different than what we've done. This is a problem where we're going to have to split it up into 2 different problems. There's no situation here where we've got a sine here and a sine there. So what this is going to look like is the limit as x approaches 0 of a sine 2x over 1 times a 1 over sine x. So all I've done is made this its own fraction over 1, and then this was the 1 over sine x. And if you don't believe me, just multiply straight through. 1 times sine 2x is this, and 1 times sine x is that. All right. Well, we know that this is equal to the limit as x approaches 0 of sine of 2x times the limit as x approaches 0 of 1 over sine x. That was just our multiplication rule for limits. We've learned that right in the beginning. But now we need to create matches. All right, and what I'm going to do here is I'm actually going to divide this by 2x. And let me put that in a different color just to say, hey, that's not part of the original. I'm going to divide this by 2x, and I'm going to multiply this one by x. So do the x's matter at all? Well, not really, because I've got an x in the numerator and x in the denominator. So that's good news, right? An x divided by x is 1. So these two things right here, they've not changed the problem at all. However, I have divided by a 2. And I can't just simply divide by 2 without multiplying by a 2 out in front. So I can take that 2 and pour it out here. So now I'm left with 2 times the limit as x approaches 0 of a sine 2x over 2x times the limit as x approaches 0 of x over sine x. Well, my 2 I'm going to write down first. What's the answer to this? Well, that's simply 1 times, what's the limit of this? Well, again, that's also 1. So my answer is 2. All right. Here's another one, and I think it's our last one. Nope, we got a couple more. Here, I need an a down below, which means I'd have to multiply by a out in front, and then I'll pull this out. So this will be a times the limit as x approaches 0 of a sine ax over ax. This whole thing becomes 1, and I've got a times 1, which is a. Yahoo! All right, these look a little closer to the ones that you're going to do on your P set, specifically the first one. All right, well, we can rewrite this one as the limit as x approaches 0 of sine 3x. And I could split it up into another limit, but I'm not going to do that. I'm just going to have times 1 over sine 2x. And like I said, like on the last one where I split it into, I guess second to last one, where I split it into a limit and another limit, you can do that if you want, or you could just keep it as two fractions being multiplied like I've done here. It works fine the other way, either way. All right, I'm going to go to a different color here, and you can see that I'm going to need a 2x here, and I'm going to need a 3x here. Well, the good news is I've got an x and an x, numerator and denominator, so those x's cancel out and we're basically left with 1. But I've multiplied by 2/3, which I can't do unless I multiply by 3/2 as well. So by having a 3/2 and a 2/3, those two things are going to cancel, which essentially means you're multiplying by 1. All right, let's go ahead and get this answer. This 3/2 comes right out in front, so you're going to left with 3/2. The answer to this limit is 1, and the answer to this limit right here, the limit as x approaches 0 of 2x over sine x, that's also 1. So our answer is 3/2. There we go. Okay, here we go. This one is going to be rewritten as the limit as x approaches 0 of sine 2x over 1 times 1 over sine x. Change colors here. Obviously we need a 2x here. We need just an x here. And if I've multiplied by x divided by x, that's good. That's a 1, so we can do that. But we've got to divide by 2 here, which means I'm going to need a multiply by 2, so that 2 divided by 2 is 1. Because we can't multiply by anything besides 1. Now I'm going to take this 2, and pull it out. So that 2 is going to go out in here, and I'm left with 2 times the limit as x approaches 0 of sine 2x over 2x times x over sine x. Well, that answer is going to be 2 times 1 times 1. So this whole thing is really about multiplying by something, like in this case 2/3, but then having to combat it or battle it by multiplying by its reciprocal, so that in reality you're just multiplying by 1. All right, thanks everyone. I know that that's a challenging one. I'll see you soon.